Okay, I got it working.
Do you?
I do indeed. I was going over one more example of the, there's like a known base and then known cross sections. Then I was going to go over one more example. I was going to finish explaining the whole washer idea. It's actually a pretty simple idea from geometry. And then maybe do one more example of a solid of rotation. All right, so 4. 4 says, find the volume of a solid whose base is this circle. Does anyone know what this circle's name is? Circle.
X squared plus y squared equals 1.
True. It's the unit circle.
Oh.
Yeah. Radius is 1. That's the unit circle. True.
Does anyone know his name?
It's George.
I just find it interesting because a lot of people understandandly think that the unit circle is when you have those pi over 6 and pi over 4s on. No, those are just noteworthy points on unit circle. The word unit just means 1. Okay. So the cross sections are squares perpendicular to the x-axis. So let's draw one of those cross sections. Okay, so I'm going to extract that. So hopefully you can imagine these poking out of the board. Right?
Indeed.
So at the middle, what's the dimensions of the square in the very middle? 2 by 2, right? And then whereas a square over here might be, it's going to be significantly smaller, and then they actually kind of converge at a point here. So anyway, let's draw this little slice. There's the slice. How thick is it?
X.
The x. And then this is the tricky part, the height. Those are, of course, the same size because it's a square. Does anyone think they know? Trey, anyone else? Anyone else? I'm just generally curious, how do we feel? I have no idea. Yeah. Let's give Laura a shot. What do you think? Let's start with solving for y. So if I solve this for y, what do I get? Yeah. Now you could think in terms of subtraction, but it's actually, I think, a little bit easier. Think of more of like addition or doubling, right? So this distance is the y value, right? So what if I just double that? So the height of this square is 2 times that y value. How are our feelies about that? Feelies engaged?
You're engaged.
Soon I won't have feelings.
Yeah.
As the nanobots take over my brain.
Your brain?
I will be operating on pure, cold machine
But
logic.
does that mean you don't have feelings, or you just
I do
they're
now.
shut off?
Obviously, I'm full of feelings now. I don't
No,
know.
but will they still be there, or will
Nope.
but where do they go?
The abyss.
Nanobot area. Yeah, the abyss, exactly.
So you're not like a Vulcan.
I don't think so. That's a robot.
Like the
That's
Borg.
alien, right?
You're bored.
Okay. The
But
volume
the
then.
Borg still have
Borg.
feelings. You just
The volume
okay.
is the volume of this slice. The volume of this slice is its area multiplied by its thickness. So the area would be this times itself. So it would be 2 times the square root of 1 minus x squared times itself, multiplied by the thickness, dx. And then to get the total area of the solid, you integrate from -1. Isn't that lovely? It is.
It is.
Don't lie. So
Don't lie.
the calculation part is not. Yes.
Could you look at this? Oh, I mean, what I started, I know I probably did it wrong, but I started as looking at it as a semicircle, and I was just gonna multiply it by 2 at the very end. But it would be easier to look at it as a full circle.
I'm wondering if you can do that, but multiply it by 4, because here's the thing. So if you do, Lillian, what upsets you, young Padawan? Okay.
Young Padawan.
Okay, I'm glad to hear that. So Aiden, if you look at,
Cut along.
say this, if you do it that way, then think about your slice right there. That middle tile would be a 1x1 square, right? Whereas this one, our middle guy would be a 2x2 square, so 4 times the area. So I am wondering if your method is exactly 4 times smaller, but that gets into, I mean, I'm not sure actually. It might be.
That's just how I started.
Okay, but you see why it's like not gonna be, certainly not double, because like, for example, the tile I'm talking about is 4 times smaller. So I think it's gonna end up being 4 times smaller, but I would certainly advise against that kind of approach, because it's very tricky. It's never super obvious when it's gonna work. What you could do in this one though, is you could go from, we certainly know that the whole shape is symmetrical over the y-axis, so you could go from 0 to 1 and double it.
Okay, that's fine.
You understand that? So I don't know. I think I'm gonna just keep it like that for now, because it's good to mix things up, right? So what happens when we square this expression?
You get 4 times 1 minus x.
-6.
4, yeah, so 4 times 1 minus x squared.
And you can take that out. Wait, no.
You could pull the 4 out, yeah,
Okay.
or just write it like this. I mean, I think either one is fine. Do we understand going from here to here?
Yes.
But
The intermediate step I didn't really show is this turning into 4 times 1 minus x. Because when you square the square root, it basically just knocks out the square root bar. Z-radical. Okay, and then you distribute the 4. We're sure we're okay with that?
You.
Yeah.
yeah.
Okay, so integrate. Get 4x minus 4/3 x cubed. It's always good to know the whole doubling idea, because here now, when you plug in 1, you're going to get a number. When you plug in -1, it's just going to be the opposite of that number. So effectively, it'll be a number minus its own opposite. So let's plug in 1. Here you go. It's 4 minus 4/3. When you plug in -1, you get -4 plus 4/3, the opposite number. So yeah, so 12/3 minus 4/3 is, so basically just 8/3 minus -8/3, yeah, plus 8/3. 16/3. That's kind of a neato number.
It's okay.
Well, it's kind of weird.
Yes, it is.
You would think that like it would be like a really perfect number.
It is a circle. You would think it would be nicer.
Well, because there's a circle, you might suspect that there's a pi in the answer, but there's no pi, so that's kind of interesting, I think. Anyway, because the volume of a cylinder has a pi in it, the volume of a cone has a pi in it, the volume of a sphere has a pi in it. So most shapes that involve a circle have a pi inside. Not this one. It's a rational number. Wheel. Namast.
Yeah.
That aligns my chakras bigly. Yes. I like your earrings, by the way. Is there like a name for those?
Earrings?
No, just,
They're beaded?
Yeah.
Earrings.
I wasn't sure if that was like a special kind of thing. They look pretty sweet.
Thank you. My aunt beaded them.
Huh?
My aunt beaded them.
Oh, that's
Is your
extra.
grandma done with your cap yet?
Almost. She just has to do the corners.
I just picked up my cap. I'll have to decide what to decorate the top with. And then maybe I'll have them paint something through the
I would love
Thank you. I'll pick an image. It'll be fun if I'm flipping somebody else.
Yes.
Yeah. So if your cross sections are perpendicular to the x-axis, then the dimensions of your
I suck at
slices
crossing
are always
words.
going to
I
be
don't know
like
why I'm looking at this.
they are y values, but they're going to be in terms of x.
German.
Like on that question, we wanted to solve for y, and then in our integral was all x's. Make sense? I just realized something about your graduation.
What?
Huh,
You're the class of
21.
21.
Yeah, we are the meme number.
meme number. That's so funny.
That was a big thing in 8th grade there.
That's the height of humor.
That's the height.
height of humor.
I said it was peak.
That's intellectual
Height.
humor. Only intellectuals can understand.
Right.
Like Griffin, he's seen Rick and Morty, so he understands. Shout out to Griffin.
He was quoting that.
Only
the other day.
high
Yeah,
IQ
Griffin, I
individuals
have
can
something
appreciate
for you.
21, the meme number.
That was,
Well, that sounds really creepy.
yes.
What I do, you need, if you're
Just text
acting on something.
Just test.
Okay,
He's not gonna see this until tonight.
Yeah.
so
Well, I know later. I'm not gonna give it to him today. Just saying.
I have something for
we are
you.
going to.
Can we finish?
Oh, I gotta talk about the washer thing. So this isn't even calculus or even like algebra 2. This is like very basic stuff actually, but you gotta know it. Circles. So a washer. So suppose I had. I'll do a really simple example first, which is what if I had a circle that had a radius of 5, and then I cut out from that a circle that had a radius of 3. So then the outer circle is a radius of 5, the inner circle is a radius of 3. And suppose I wanted to know how much area was there left over. Okay. So the procedure there would be, well, you take the total area, 25 pi, and subtract the inner area. So the answer would be 16 pi. So are there any questions on that?
No.
Right?
Yeah.
Okay, now notice what we didn't do, what a lot of beginner students, middle school students might go, oh, I'm just gonna subtract the 5 and the 3 to get 2. What answer would that lead them towards? They'd get 4 pi as their answer, right?
Yeah.
So now what happens to the calculus student is they forget that really simple result and they get tempted to subtract. Because think about for us, really what's gonna happen is you're gonna have some function f, some function g, and say here's your region, and say you're revolving that region around the x-axis. Well, what is each cross-section going to be? I mean, imagine that slice carving itself out. Can you see it?
Mhm.
It's going to be a washer. And then what's going to be the 2 radii involved? Well, the big radii is the bigger function, right? F, and then the little radius is g. And so if you wanted to look at, and of course the thickness of this would be dx. And so the integral here would be, you could go integral of, back up. So we talked about yesterday at the very end was you could go, well, pi r squared minus pi r squared, right? Big circle minus little circle. But what's to stop you from just lumping it all into one? So
No.
this is sort of the big idea that I wanted to. You could do that. Yes?
Mhm.
And then that's kind of the same idea as this, right? Like what's the area of this circle? Well, it's pi times 5 squared minus 3 squared. So the big idea is you square them, then you subtract them. You don't subtract them, then you square them.
Yeah.
Big
Make sense?
brain.
No one's confused? Okay, let's do an example then.
We-
What?
Can we finish 14? We never finished it.
It's right there.
That's the answer?
Well, then you evaluate it.
We'll do that. Yes. Never mind. Continue. I'll figure it out.
Well, you evaluate it the same way. There's nothing new there. You just apply the add 1 to the exponents, etc.
Yes.
Let's look at 15. And so tomorrow I'll talk about revolving around the y-axis. Okay. So One quick example, 15. You got 3 curves. What do these curves look like? There's 2 straight lines, yep. There's x equals 0, looks like this. What's the other one look like? All right. 1, 2, tie my shoe. And then what is that? X to the 3 halves. Who dat? Birdie is actually the 2/3. So X to the 2/3 looks like.
X to the 3 halves is like, it's like this. It's kind of like a.
Also remember, the fact that this is bigger than 1 means that it is concave up. So it's going to look something like this. So where's the region bounded by those 3 curves? Is it A or B? A. Very good. All right. Do we see the washers?
Yes.
Can you picture them? This is kind of a weird shape. It's kind of like when you revolve this. I don't know. Do they don't have a descriptor for that?
No.
2 traffic cones.
It's like,
But it's-
Or no, it's just gonna be a
like-
triangle.
It's like
It's like
Is it?
a little, like a bowl, but with weird, it's not really like a bowl, it's like, it's like,
Ice cream.
wee.
I don't think there's something to
Yeah,
describe what
there's
that
a-
shape is supposed to be.
Yeah, okay, so you can describe it. The bottom would be a circular base, so it'd be a circular base to it.
With the diameter.
And then the top has sort of a circular rim. And then the outer part is kind of like, is a cone actually, has a conical outside. But then the interior has this this would be a terrible cereal bowl
Like a dog bowl.
because it's concave down into the bowl. So
So there's gotta be something that looks like that.
does that make sense? It's kind of like a volcano or something.
Let me rephrase my question, my statement. There aren't a lot of items that I could use to describe what that looks
Yeah,
like.
that one's a weird one. I don't know, some kind of weird lampshade, some kind of like hipster lampshade.
Lampshades.
Dude,
Let's
that'd
talk
be
about
cool
lampshades.
But the
Why?
important thing is, I'm just trying to see, can you visualize what this looks like?
Yes.
Of course, I turned it sideways. I rotated it in my mind and then I turned it sideways. Make sense?
Yes.
Okay. So let's examine one of the washers. So take a slice,
Ah, sure.
take a slice, rotate it around. Some people like to draw it on the shape. I think that's kind of clutters it up a little bit. It's totally up to you. I'm going to draw my washer though. There's a hole in the washer. Okay, so the outer radius is which function? Which
The
The
2 minus x.
2 minus x. You understand that? That's the outer radius. Like this.
Mm-hmm.
And what's the inner radius?
The x to the 3 halves.
X to the 3 halves. Yes?
Mm-hmm.
Thickness?
Yeah.
dx. Okay, so the volume would be,
So can we just go straight to pi?
yep, so pi times, so the general idea is pi times, you can write it like this too, you can call it big radius squared minus small radius squared. That's another way to, if that makes more sense to you to write it that way. But in any case, it's going to be this squared minus this squared. So this squared minus that squared. Uh-oh. Is this going to be annoying?
Yeah.
Oh, by the way, what
Yeah.
are the bounds?
0 to 1.
0 to 1. Okay, don't be scared. This is actually an easy integral.
Okay.
And I say that because it doesn't involve any u substitutions, doesn't even involve any like u primes, doesn't involve any manipulation. It's just going to expand out into a polynomial. So you're gonna have here, this expands into 4 minus 4x plus x squared. And what does this turn into?
X to the
X to the third. And so integral. Let's integrate each term. 4x minus
X squared.
2x squared. I want to put that inside the brackets. Okay.
You want this right now? Or?
Yeah. Yeah. Okay, so plugging in the 1 gets us. What do we get here? 4 minus 2 plus a third minus a fourth. Plugging in 0 just gets us nothing. So that's nice. Let's see. You can probably do this one mentally, right? This is 2, right? The 3 and the 4 tells us it's got to be in twelfths. So it's 2. So that's going to be 24 twelfths plus 4 twelfths minus 3 twelfths. So really just plus 1 twelfth. So 25 twelfths. Do you feel okay about that?
Yeah.
Don't forget the pi in your answer. 25 pi over 12. And if you're feeling unsure, of course, a computer will always be able to tell you the answer. You can just plug that straight in and then just compare it. Keep in mind the computer's going to tell you a decimal. It's going to be like, oh, it's roughly 6.5 or something. What? Thanks, Jessica.